The second derivative test. As we learned in the Year 11 course, we can identify stationary values by finding x coordinates where dy dx is equal to 0. We know that we can use a sign test to determine the type of stationary value. We can also use the second derivative. If d2y dx squared is greater than 0, we have a local minimum because we know that the curve is concave up for these points. So we're going to have a shape like this if it's concave up, and therefore if we have a stationary value, it's got to be a minimum. If d2y dx squared is less than 0, we have a local maximum for the opposite reason that we know that the curve is concave down. If d2y dx squared is equal to 0, it could be any type of stationary point, as we have seen in earlier examples. So in that case we need to do something else. And we can either revert to a sign test, which we've met in Year 11, or look at d2y dx squared either side of the stationary point. Now this is new to us, so let's have a look at that. So if we have a curve that's concave down over here and concave up over here, we have a point of inflection. And don't forget, concave down, that's when d2y dx squared is negative. Concave up is when it's positive. So if d2y dx squared goes negative 0 positive, then we have a horizontal point of inflection. And we also have a horizontal point of inflection if it goes positive 0 negative, because concave up followed by concave down means we have a point of inflection. If it's concave up, then we must have a local minimum. So concave up means that d2y dx squared is positive, then becomes 0, then becomes positive once again, so that's concave up, and then if the curve goes from concave down to concave down, we have a maximum